And do remind me that I have to send you the previous recording. Okay. So now we are going to do Boltzmann, Maxwell, Boltzmann distribution. Boltzmann distribution. Okay, now what is Maxwell-Boltzmann distribution? Okay, the distribution is basically that we are having three, like over here, if you have the number of molecules, number of molecules, okay, we have three categories of energy. Okay, now what are the three categories of energy? Now, when you will see the Boltzmann graph, it will be in this way. It is in this way, which shows that this is the basically this is the distribution. Okay, this is the distribution. Okay, now this is the part where the molecules, they are having less energy. Right. Okay. Now the middle part, this part, this is the portion where the molecules, they have moderate energy.
Yes.
Okay, and over here the particles or the molecules, they have higher energy level. Got it? So this is the less energy level for the molecule, this is the moderate energy level for the molecule, and this is the higher energy level for the molecules. Okay. So
how
now
is
what
it higher
happens?
energy if they both are in the same line?
Higher energy what?
No, I was asking, how are they higher energy when they are on same
They
level?
are higher, see, they are of higher energy. That means over here, the particles which are present, they are basically going to give you products. Remember, when we were doing kinetic, when we were doing chemical energetics, I told you there should be a successful collision. Okay,
Yes.
so do remember that these are the particles with a higher energy level which are going to give you the successful collision by making products. The less energy level molecules and the moderate energy level molecules, they are not capable of making products. Now did you got it?
Yes.
So this is the particle, this was the basically particle division which Boltzmann gave, that a bit of the particles, a bit of the molecules, they are able to give products. Though all molecules, they keep on colliding, but what happened? Some of the particles, they just have a lower collision, they stay where they are. Some of them, they enter into the moderate position, but they also do not convert into the product stage. Okay, and some of them, let us say that 20 is over here, 20% is over here. Mostly what we say that 60% part is of moderate level. And that means 20% goes for the basic production of products. Got it? So 60% is the moderate level. Got it? So this is basically the distribution which Boltzmann gave. Now to make this 60%, because they are in vibration, you can just convert this 60% also in product formation. How? By either increasing or decreasing temperature. Two steps he introduced. One was the temperature and one was the catalyst. Temperature and the other is catalyst. Now, what will be the effect of these two on this graph? Okay, now, in case, if you are having, okay, this is what we call that as an activation energy. Okay, energy required to make products. Okay, this much is the activation energy. I have written higher energy level. That means this is an activation energy level. Okay, so this is an activation energy level. Now, In case, what happens if you increase the temperature? As I told you that two things will affect this graph. One will be the temperature, the other will be
Yeah, the
what?
temperature
Other will be
and the catalyst.
catalyst. Okay. Now, in case, if you are having the temperature, okay, now what is going to happen? Let us draw a graph. I have two temperature levels. Okay. One temperature is lower and the temperature is higher. Okay. Now, see, do remember that over here, this is T1. Let's suppose that this is T2. Now, if you see the level over here, see, over here, if you see, this is the point for activation energy. Let me draw in another way so you are able to see it. Okay, see, I'm drawing it again for you. This is my one temperature, okay, and this is the other one. Okay, now let's suppose that this is the energy level. Okay, now see over here, if you notice that this one, this is T1, this is T2. If you notice T1, for the T1, this whole space comes in an activation energy. That means you will be having what? You will be having a lot of molecules. You will be having a lot of molecules in T1 and in T2. If you see T1, what happened? A lot of molecules, they are there to make product, isn't it? This is T1. A lot of molecules are there which are capable of making what? Which are capable of making products. Now, if you see the lower one, this one, the T2. So the T2, if you notice, let me do it with the color. For T2 is, if you notice, there are just this much. This is T2. There are just this much of particles which are making your product. So what happened as you will increase the temperature, what is going to happen? We are going to write that T1 is greater than T2. Can we write it? That T1 is going to give you more product formation than T2. Because as we increase the temperature, what will happen? You will be getting more and more product formed. Okay, by increasing the temperature, what has happened? See, by increasing the temperature, what has happened? More and more product is formed. See, the energy level has, see over here. Just check this one. This is the energy level for T2. Getting it? This all is the energy level for, sorry, this all is the energy level for T1. Over here, let's suppose the temperature I have increased to 80. Over here, the temperature is 60. So the higher temperature is going to give you more products. Getting it?
Yes.
Now, see the other one. This is what? This is for T2. Now over here, small particles, less particles are over here. See? The range became for T1, you are having all of this. For T2, you are just having this part. Getting it? You are just having this part. So by increasing the temperature, what has happened? You are going to get more and more particles to make the product. So what we can write over here? We can write that T1 is greater than T2. Why? Because more molecules have energy greater than the activation energy greater than activation energy. Okay. As you will increase the temperature, what will happen? The space will become more. Got it or no?
Yes, got it.
Okay. Now, same thing if we are having a catalyst. If we are having a catalyst, what is going to happen? For a catalyst, what you are going to do, simply you will be making just one graph. In that graph, make the graph as Boltzmann gave. Okay, now what has happened? If you were not having a catalyst, this much was the activation energy. This much was the product you were getting. And as you added the catalyst, now this much product are also included. So just make a line and put TA over here. This is with catalyst. This is temperature one is a bit difficult, but catalyst is the easier one. So you are just going to make this in this way. Both graphs can come. One of this is the must to become. So you have to learn both of them. Okay. Molecules with a given energy. Got it? So this is what you are going to write. Okay. So down what we can write more molecules have energy higher than the energy of a higher than activation energy. This is what we are going to write for the catalyst. Got it? This is the effect of catalyst. This will be the effect of catalyst. Now, what is the effect of the solid catalyst on basically gaseous reactants? What will be the effect of the solid catalyst on gaseous reactant? Action, we can write it as action of solid catalyst gaseous catalyst. Gaseous reactant. Now, do remember that what happened. Now, let's suppose that we are having a catalyst over here. This is the surface of a catalyst, okay? Okay, now what is going to happen? The particles, they will come and they will be settled. They basically settle down on the surface of the catalyst. Okay. And what will happen over here? Like they are coming, let's suppose that this is particle A and this is particle B. So what will happen basically when you are having the particles, they are coming on the surface of the catalyst, what they will do, this is your particle B again. Okay, and this is your particle A. So what is going to happen? Your catalyst is going to help these both reactants to come and meet each other, to come and make a reactant, come and make a product in such a way, in this way. They come and settle down on the top of each other. And in return, what they are going to give you, they are going to give the product in this way, helping the reactant to react. So we can write it as that reactants are adsorbed on the surface of the catalyst, which weakens the bond. Okay, which is going to weakens the bond. Okay, weakens the bond in the
Right, so
reaction.
basically the B ones are the gases and right?
A1 is also gases, B1 is also gases. Okay, what happened? Let's see if I am having hydrogen gas, if I am having chlorine gas. Okay, these both are gases and they want to react together. So I have used a catalyst in between to speed up their reaction. So what will happen? First of all, these
Okay.
catalysts, these gases, they are going to break. And after breaking, what will happen? They are going to make the product with each other in this way. So breaking and making take place basically on the surface of the catalyst. This is what catalysts help us to do. Okay.
Yes.
So it speed up the chemical reaction. So it speed the reaction. This is what the catalyst basically do. Okay. And the product separate. Now what happened once the product is formed? See over here, when the product is formed, it gets separated from the surface. So as product is formed, it separated from surface. This is what the catalyst basically do. Got it?
Yes.
So this was all for the reaction kinetics. So our reaction kinetics chapter is done. What you want to ask something, you can ask me, because till here any confusion you want to ask me, you can ask me.
Yeah, could you please explain the that graph about the picture one again
Which one? Just let me know.
for the catalyst one?
For the catalyst one, so just write it. This one?
The temperature one.
The temperature one. Is the
Yes.
temperature graph. Okay. What is basically happening? Like, see, I have written two temperature. One is the higher temperature, one is the lower temperature. Okay. As you have a higher temperature, what happens? The particles, they start converting into product very fast, isn't it? So we can write at a higher
Yes.
temperature, at a higher temperature, what happened? The product, we can write more product on it. Okay, more product on it. More product are made. Okay, now if more product are made, you can see that this is the complete ratio which is going to give you product. See, this is T1 at higher temperature. This is the ratio which you are getting for the product formation. But if you were having a lower temperature, then what? You will be having less molecules which are going to give you the product, this much of the molecule. See, this is the percentage of the molecules which are going to give you product. Getting it? So at lower
Yes.
temperature, low product formation will be there, and at high temperature, more product formation will be there.
All right, got it.
Got it? So this is the difference between both the graphs.
All right.
Okay, so this is the end of the chapter. We are going to start with chemical equilibria, which is the next chapter. And after this, just an organic one is left, okay? What is chemical equilibrium? What is chemical equilibrium? Or chemical equilibria, you can say. Chemical equilibrium, you can say. Hello? Hello? Chemical equilibrium, chemical equilibria, both mean the same thing. What does this mean? Do remember, have you ever seen that when we are doing a reaction, somewhere we write, like see in somewhere you will notice that we have written just an arrow between both of them and we are writing the reaction in this way. Somewhere what we are doing, we are making the reaction in such a way that you are having this sign in between.
Yes.
So what is the difference
Yes.
between these two signs?
In the first one, it says that uh, these atoms like element
Okay, elements.
HCl, and in the second one,
It can be reversed, isn't it? So if in the first one, this reaction basically cannot be reversed, isn't it?
yes,
And this in the second one, when this arrow come, that means the reaction which can be reversed. So equilibria is established whenever you are having reversible reaction. And equilibria always established when you are doing a reaction in a closed container. Okay, like see, if you want to convert liquid to vapors, what you do, you just keep a lead on over it. What will happen? The liquid is going to convert into vapor, and they keep on interchanging each other. And vapor will come back to liquid, liquid will go back to vapors. So that means an equilibrium is established between both of them.
yes,
Okay. This happens when you will be keeping a cover on water what you are boiling, and that water vapors, they will keep on going into water again and again.
right.
So
Yes.
if this thing happened, that this is called as a reversible reaction, and this happens in a closed container. And what do we have over here? Do remember that this is called as that the reaction which goes in forward as well as in backward direction. Okay, so for the reversible reaction, what we can write? We can write that the reaction which goes in forward and backward direction which without going to completion, without going to completion. That means final result is not obtained. They keep on just changing in each other. Okay.
Yes.
So this is final completion. And this is not a final completion. So we write this as that reversible reaction is the one which goes in forward and backward reaction without final completion. Okay, now we can have an example over here. Like see if you are having copper sulfate with water molecule, hydrated. We call this as hydrated copper sulfate. Hydrated Okay. Do remember hydrated copper sulfate is blue in color. Hydrate mean with water.
Perfect. Yes.
When you remove the water from it, you will be getting copper sulfate and water removed. So this is called as either anhydrous. We call this as anhydrous. anhydrous copper sulfate. This is white in color. What happened? These both can be interconverted into each other. Like anhydrous copper sulfate can go into hydrated copper sulfate, and hydrated copper sulfate can come back to anhydrous copper sulfate. So equilibrium is established between both of them. You have to learn this equation, this chemical equation, that anhydrous hydrated goes into anhydrous and anhydrous goes into. Just 1 second, just give me 1 second.